So it is last topic, only new features. What are the new features are there? 1.1 onwards up to JDK 20 list I'll teach. Some features already covered, which are not covered, I'll teach. JDK 1.0. JDK 1.0 introduced in 1995. JDK 1.0 introduced in 1995. It is initial language. JDK 1.1. JDK 1.1 in 1997. One new feature, inner classes. Say JDK 1.0 first version that is introduced in 1995. That is only starting language. At the time, total Java is new. Total Java is new only. Okay. Next version onward, new features comes. So 1.1, 1997, inner classes introduced. Inner class completed. No? How many types of inner classes? How many types? 4 types. What are those? Member class, static member class, local class, anonymous class. Okay. Anonymous class most important for tomorrow, day after tomorrow also required. You prepare and come. Anonymous class already covered. That is required for learning lambda expressions. Okay. Next, JDK 1.2, 1998. Strict FP keyword. JDK 1.2, 1998. Strict FP keyword introduced. JDK 1.2, 1998. Only this keyword introduced 1998. Actually, new features divided into 3 categories. New features. One category, language changes, language related. One more category, internal JVM related. One more category, library related, Java API. So, new features, language features, library features, JVM features. Language features you are learning, but library features no need to learn because 1.0 library also very vast. And JVM feature, internal feature no need to learn. So here new features means 3 categories divided: library changes, language changes, JVM changes. For you, language changes only required. Library changes not required. Library every day they are updating. Every day they are updating. Okay. That much vast library is there. It is not possible to learn 1.0 library also. Okay. If you want to learn each and every library, every method, every class, every function, every package, it will take 25 years, 30 years also. If you learn that much library is there. Okay. So that is not possible to learn. No one can learn that much complete library because hundreds of packages are there, thousands of classes are there, lakhs of methods are there. Lakhs are there. So you have seen already while opening Java P command, so many coming. Just I'm taking only 4 or 5 methods. I'm explaining, finishing like that only. But each and everything if you learn, years it will take. Okay. Now, here what you are learning is language features only you are learning. Okay. That's what here. Starting what they did, they concentrated on library. That's what language features are less. So 1.1, only one concept, inner classes. 1.2, only one concept, strict FP keyword. JDK 1.3. JDK 1.3 in 2000. No changes at language level. Changes are not there. No changes at language level. No changes at language level. JDK 1.4 in 2002. JDK 1.4 in 2002. Uh, 2002 JDK 1.4 came. One new feature came, assertions. Assert keyword. JDK 1.4 2002 assertions. JDK 1.5 2004 enhanced for loop. We can also call for each loop. Enhanced for loop or for each loop. Covariant return type. Auto boxing and unboxing. Var aux. Static imports. Enumerations. Enum keyword. Annotations. Generics. So JDK 1.5, 8 features newly added. So 1.5 new features, many came. On JDK 1.6, 2006. No changes at language level. So 1.5 new features, 8 features came. JDK 1.7, 2011. JDK 1.7, 2011. New features. Binary literals. Underscores in numeric literals. Underscore symbols in numeric literals. Strings in switch statement. Try with the resource statement. Handling multiple exceptions with single catch block. Generic type inference. Generic type inference. Inference means allowing. Say total 6 features in 1.7. Say 1.5 they concentrated on language. 1.7 they concentrated on language. But remaining versions they concentrated on library. That is the reason new features are less. Language features are less. So nowadays library they are updating every day. Language features are less. Like 5th version, 7th version, language features changed many. 8th version, 8, 9 also, many changes are there. First up to here I'll give. Up to here I'll explain. After this Java 8 we'll see. Java 8, 11 features are there. I given already list. First up to here I'll complete. Then we'll see 11. Okay. First up to here I'll complete. After that Java 8 we'll see. Java 8, 11 features are there. 11 features. Now, up to here we'll see first. In these all, some features already completed. 1.0 initial language, starting language. 1.1 inner classes. There are 4 types of inner classes: member class, static member class, local class, anonymous class. Those all completed. Strict FP not completed. I have to teach. No changes. Assertions, assert keyword. It is not completed. I have to teach. Enhanced for loop completed. No. Enhanced for loop completed. Covariant return type also completed. What is covariant? While writing return type, subclass type. Okay, overriding. While overriding a method, return type will be subclass type. That is. Auto boxing, auto unboxing completed. What is auto boxing? Converting primitive type to the corresponding reference type into integer. Example. Converting reference type to primitive type, unboxing. That is over. This is not completed. I have to teach. It is completed, no? What is the use? Static keyword. If you attach to import keyword with the following classes, what will happen? All static members without class name you can access. You can avoid class name with static members. You can avoid class name with static members. Okay. Like system.out.println, no need to write. Out.println you can write if you use that feature. It is not completed. Enumerations. Enumeration interface, that is different. It is enum keyword. Okay, this is not completed. Annotation not completed. Generics completed. Type safe programs. It is no changes. Binary literals completed. No? 0B, 0x, octal, hexadecimal, decimal, these all completed. Underscores not completed. Strings in switch statement not completed. Try with resource completed. Handling multiple exception with single catch block completed. Generic type inference nothing but 2 sides integer, no need to write. 1 side only can write. That is inference. 2 sides integer, no need to write. Okay, that is inference. Now Which are not covered, those all I'll teach. Which are not covered, those all I'll cover. It is completed. 1.1 completed. Now strict FP. Note. Strict FP keyword. Strict FP keyword. It ensures that to get same result on any platform while performing operations on floating point numbers. It ensures that to get same result on any platform while performing operations on while performing operations on floating point numbers, you'll get a same output if you use strict FP keyword. Actually, you observe one example. You observe float A equal to one number, float B equal to one more number. Now system.out.println A into B, if you write. Now result of this output, you observe Java C demo.java. I given both same. Which program? A already given here. Okay. This aux also you can write, any name also you can write. Okay. It is not compulsory to write aux. A also okay. But here one more A you cannot write. That is the reason error. Okay. Now. Say compilation, execution. You are getting something 21.130455. Okay, like that you are getting. Here actually, this is actually truncated. Like maybe some other also comes. You just observe 5.394 into 3.9174. If you multiply, you observe here 5.394 into 3.9174. See what you are getting? 130,456. But what is the output coming? You observe. What you are getting? 455. So actual result is, see, 130,456. But that 6 truncated, not there, you observe. Okay. Here total, how many digits are there? 7. Here how many coming? 6. It is happened, no? Now, this program, if you run in Windows like this, you are getting. If you run in Solaris, if you run in Mac OS, if you run in Linux, result may be different. Result may be different. Here 768, there 7 digits are 55, 556, like that different comes while performing operations on floating point numbers. In that situation, if you write one strict FP keyword, if you attach, then on any platform, you'll get a same output. Compilation. Now, it is just you observe, warning. As of Java 17, floating point expressions are evaluated strictly and strict FP is not required. So 17 onwards, this feature is not required. Changed. By default, strict FP. No need to write. So strict FP keyword, no need to write. Strict FP is not required. But it is warning only. Java demo. You'll get this output, no? If you write strict FP, without strict FP, difference is different platform, different output comes without strict FP. But with strict FP, on all platforms, same output comes. Java is a platform independent only. You can run on any platform. Output, decimal point, somewhat different comes. In different operating system, different types comes. If you write strict FP, same comes. That is the concept. That too, this is not required from latest versions. It is not required. By default, strict FP is there. So that's what warning message coming. Okay. Now next, write it. Strict FP keyword can be applied to methods, comma, classes, and interfaces. Strict FP keyword can be applied to methods, classes, and interfaces. Strict FP keyword can be applied to methods, classes, and interfaces. So this keyword can be applied to methods, classes, and interfaces. But you can write here also. Strict FP. It is also valid. Latest version doesn't record strict FP. But you should not write with variable. It is you should not write. It is not allowed. See, error. Class, interface, enumeration or record expected. With the class you can write, interface you can write like that. It's an error. With variable you cannot write. This is performing operation. Operation code you will write inside the method only. That's what method you can apply. And the latest version of Java doesn't record strict FP. Note. Latest version of latest versions of Java does not require strict epic keyword. Online students, it was disconnected. Okay. Now, latest versions of Java does not require strict epi keyword because by default strict epi present. Okay. Now, this is one example. Note on. You can write strict epi here or there. Any one example. Ready, son? So no need to write strict epi in latest versions. Over. So you can write, you can apply to method, you can apply to class, you can apply to interface, but you cannot apply to variable. Is it completed? It is not required also because latest version are by default working. Okay. Now strict epi completed. JDK 1.3 no changes. Next assertions. It is also not important. Assertions. An assertion is a condition that must be true during program execution. An assertion is a condition that must be true during program execution. An assertion is a condition that must be true during program execution. I'll explain what is that. Next, write it. Assertions are used to identify logical errors. Assertions are used to identify logical errors. In order to use assertions, assert keyword and java.lang.assertion error class were introduced in JDK 1.4 version in 2002. In order to use assertions, assert keyword and java.lang.assertion error class were introduced in JDK 1.4 version in 2002. So if you want to use assertion, assert keyword, assertion error class. These two were introduced in 1.4. What is the concept of this one? See, for example, is it over? Writing is over. So assertion nothing but condition. It's just like if condition. If condition will write. Assertion condition will write. Assert keyword condition will write. What purpose is to identify logical errors? If any logical error is occurred, already you studied how many types of errors? What are those? If any logical error is there, program will it compile? Will it execute? How will understand logical error occurred? Wrong output. In your program, wrong output appears, then you can understand logical error occurred. Then you have to identify in which line error occurred, what is the mistake happened. Okay. For that, we use assertions. It is nothing but in C, C++, debugging tracing. F7 will press tracing. Here also, we use Eclipse. In Eclipse, NetBeans, IntelliJ, we can use. But did in Notepad, no? In Notepad, Edit Plus, not possible. At the time, we use this concept. Okay. That's what it is not important. That too, we are not writing any logics. Already built in. Sorting also available. Searching also you have seen already. Sort method, search method, hash method, all present. We are not writing any logic. We are using only library. Then logical error will never occur. The library order may be missed. That is also you can debug. That is Eclipse debugging we use. So here, one small example you observe. You already studied scanner class. With scanner class, one program I'll write. You see, scanner S equal to new scanner. What will pass? System.in. Enter any number between 1 and 10. Suppose I'm asking user to enter number between 1 and 10 only. I'm asking. Enter any number between 1 and 10. Okay. Enter any number between 1 and 10. Then, because some logic is there between 1 and 10 purpose only written logic. But integer x equal to s dot next int. Scanner class in which package? Util package. Okay. See, compilation, execution. Now, strict TP warning, that is, I'll remove that. Compilation, execution. Now, enter any number between 1 and 10. I entered 8. Output is 8. Enter any number between 1 and 10. I entered 90. Will it print? Yes, because there is no condition, nothing. I asked it to enter user 1 to 10, but user entered 90. Accepted. Here we didn't write any condition, nothing. That's what I accepted. Suppose some logic is there, already we written between 1 and 10 purpose only written. But by mistake user entered wrong input. Then definitely wrong output comes, no? Already logic written between 1 and 10 purpose only logic. But the wrong input is there, definitely wrong output also comes. So what you can do, you can find out. How to find out is just one assert keyword, assert after that condition, x greater than 0 and x less than or equal to 10. It's on condition. I written assert x greater than 0, x less than or equal to 10. That means here 1 and 10 in between. Like that I can written condition. If it is there, next line allowed. If it is not there, next line not allowed. It is stopped there itself. You observe. Compilation, execution. Enter between 1 and 10, 8. Enter between 1 and 10. Now also 71 comes, there is no effect. Reason, by default assertions are disabled. You have to enable. So that point note down. By default, assertions are disabled. To enable assertions, by default assertions are disabled. To enable assertions, we use the following. By default, assertions are disabled. To enable assertions, we use the following. At the command prompt, Java space -EA demo or C drive Java -enable assertions demo. Java space -enable assertions demo. In a short form, EA you can write or enable assertions you can write. Okay. By default, assertions are disabled. If you want to enable -EA or -enable assertions, any one we can write. Now, you observe Java -EA. If you enter number out of boundary, see error. Java -enable assertions demo. Say number error. Okay. But this one you can write with if condition also. No? Instead of assertion, is if condition also you can use. Actually, what is the problem? Say with if condition, what is the problem? Say suppose these many lines of code already written in a program. These many lines of code written. You compiled successfully. You compiled successfully. You executed successfully. Wrong output came. But in which line mistake happened in logic? You have to find out. Then what you will do? You'll insert some assertions like this. What are you doing? Is concentrating on mobile only. While sitting in a class, listen class. Don't concentrate on mobiles. Now see, here, two assertions are included. Whenever you compile, whenever you run, suppose up to here executed, stop it. Then you can understand mistake happened here only. Suppose program executed up to here and stop it. Then you will understand mistake is here. The program complete executed after writing assertions also. Then you can understand mistake happened here. Okay, like that. Suppose you identified year occurred. Again, add some more assertions. Now, whether year occurred or year occurred or year occurred, find out. Like that. But this one you can do with if conditions. Just if else, like that, you can write. You identified with if condition. After completion of the task, again, if conditions you have to remove. Identification purpose, you have written if condition. Already logic purpose also if conditions will be there. That if condition, this sub condition, which is for validation purpose you written, which is checking purpose you have written, you cannot identify. You may remove that if condition also. If you don't remove, one more logical error. Okay. But assertions by default disabled. After finding logical error, no need to remove assertion. You can continue. Those are ignored. Well, if you don't write -EA, we don't write, that line is not, that line is ignored. It is not executed. That's what assertion better. Okay. Actually, these assertions also we don't use. We are going for Eclipse debugging further. Okay. That's what it is not important. Just one program I given. Write this program example. Is it over? If you write Java space -EA, then only you can see the effect of this program. If you don't write -EA, there is no effect. Okay. So while running the program, compulsory enable assertions or EA. If you write, then only you can see the effect. Is it over? Say, if I execute normal, if I enter any number, accepted, printed, no effect. If I execute like this, then only you can see the difference. Okay, then only you can see the difference. Otherwise, no effect. It is not important, no need to worry. Okay. Here 1.4 completed. Say 1.0 new language, Java, total Java new 1.0. 1.1 one feature inner classes already you studied. 1.2 strict FP, that is not important because by default strict FP is there now. That is not important. 1.3 no changes. 1.4 assertions, that is not important because we are using Eclipse debugging. Okay. So 1.5 here enhanced for loop or for each loop. It is already completed. What will write? If you want to write enhanced for loop, for one data type, variable, colon, array reference or collection reference. Arrays also you can use, collections also, array list, linked list, as said, those also you can use. Array list reference you can write, array reference you can write, collection reference you can write. Array reference if you write from array one element, collection if you write from collections one element, iterated. Okay. Say you have seen collections iterating with iterator interface you studied. As compared to that, enhanced for loop is very simple. No? With iterator, very complicated. First you need to call iterator method. Then you'll get the iterator reference. After that in while loop, as next, again next, as next, and again you have to try to call. But as compared to that, enhanced for loop is very simple. Okay. Now, that is our covariant return type. While overriding a method, if it is subclass type, it is called covariant. That is over. Auto boxing, auto unboxing, over. Primitive type to reference type to primitive type. Okay, that is over. Next, var aux. Var aux. It is called as variable arguments. It is called as variable arguments. You observe variable arguments. This feature here, if I write display integer A, integer B, it's on method. Is it instance method or class method? Which class object record? What we have tried? Next, how to call? Data display, two numbers I'll pass. Will it compile? Yes. Compilation, success, execution, success. Okay. I didn't write output not came, but success. If I write 3 arguments, what will be happen? Actually, it takes 2 integers. I passed 3 integers. What will be happen? Will it compile? Will it compile? No. Error comes. See, error. Method display in class demo cannot be applied to given type. Required 2 integers. Found 3 integers. Reason. Actual and formal arguments lists differ in length. Now here, which are actual, which are formal? These all actual. These all actual arguments. How many? Formal argument. Length different. No, that error came. Okay. Now, if I pass one argument, will it compile? Will it compile? Think yourself. Will it compile? No. Now also error. Same error. Same error. Length difference only. Compilation. See. Required 2 integers. Found 1 integer. Actual and formal arguments list different length. Same error. Okay. It takes 2 integers. You must pass 2 integers only. One less also error, one more also error. Less than number of arguments also error. Greater than that number of arguments also error. Compulsory 2 only you have to pass. Okay. If you pass 3 also error, if you pass 1 also error. Suppose if I write like this, it is which type? Integer array type. Is it valid? Is it valid? Think yourself. What it takes? Array type. It is array type. Now, is it valid or not valid? Valid or not valid? How many will answer valid? How many answer not valid? It is not valid. What it takes? Array type. Is it array? It is array type. It is integer type. 3 integers. See, file, save. It is not valid. See, again, required array, found 3 integers. If you want to pass array, how will pass? Is it valid? It is also not valid. Compulsory new you are right. Already taught. See how many errors coming? You must write new integer array operator. Then valid. See, then valid. It will take array type. Then array type only can pass. But if you want to pass, you can write like this if you want. Integer array x equal to year flower basis without data type you can write. It is valid. It is valid. Now x. It is valid. Okay. In this syntax allowed. See, compiled. You can write like this also. Valid. So here 2 options while passing 1 only. Okay. Compilation. See, success. Okay. Here new integer without writing also valid. But while passing compulsory array new integer required. Now, it takes array. What we have to pass here? Array type only you have to pass. Okay. Now, it is valid, but you cannot write like this. Error. If you want to write new integer array operator like this, then only valid. It takes array, I am passing array. Then valid. Actually, this concept is You can pass any number of arguments. That allows. This feature allows to pass 0 to any number of arguments to a method. It is called as variable arguments. This feature allows to pass 0 to any number of arguments to a method. Syntax. Return type, method name, data type, 3 dots, variable. Three dots you have to write. Data type, dot, 3 dots. If you write 4 dots also error, 2 dots also error. That is syntax. Okay. If you write 4 dots also error, 2 dots also error. You must write 3 dots only. Like generally, while writing dash, etc., we'll write like that dot. But syntax, you must write 3 dots only. 2 dots also error, 4 dots also error. Return type, method name, data type, 3 dots, variable. You observe here. 3 dots. Okay. Now you observe. I am passing 3 arguments. Compilation. See, success. If I pass 4 arguments, compilation, success. If I pass 10 arguments, n number of success. Okay. If I don't pass, valid. If I don't pass, also valid. 0 to any number. So I given that point. 0 to any number of arguments to a method. Okay. Now suppose I'll write 3 arguments. D.display. I'll write 2 arguments. D.display. Many arguments, valid. But how to print? With enhanced for loop, you have to print. For int b:(a). Then you can print system.out.println b. But writing only int a different, writing array operator a different, writing integer 3 dots is different. Here, main method also supports this feature. Here, you can write like this. See, here, array operator, here also you can write. Here also you can write. Here also you can write. Now here 3 dots also you can write. Valid. It supports. Because main method n number of arguments you can pass. That's what this syntax also developed for main. But array different, varchar different, not same. Array is there, array only can pass. Varargs is there, 0 to any number of arguments you can pass. Array is there, if you don't pass arguments, error. Okay, array only can pass. But here, any number. You observe. Compilation, execution. See, 3 elements, next 2, next 6, all printed. All right, this one. Is it completed? Is it over? Okay. Here, 3 arguments I passed, valid. 2 arguments I passed, valid. 6 arguments I passed, valid. Even if I don't pass, valid. Now, little bit I'll change. What will happen? Think yourself. Let us write. Now, integer 3 dots A, comma, integer B. Okay. Now, otherwise, float B. Now, D dot display. Now, what I am passing? 3 integers I am passing. 1 floating point number I am passing. Okay. Now, here, if you write like this, it's an error. This argument must be a last parameter. Say file, save, compilation. Say Varargs parameter must be the last parameter. Why this problem is? Suppose you may write like this. Okay. Now you'll pass like this. Your intention is these 3 you want to pass to this one. This one you want to pass to this one. But what system will do? These 4 it will take A only. Then next, it doesn't take. If you pass like this also, if you pass like this also, n number of you pass, A only received. Then B will never receive. Okay. This is your intention. You want to pass like this for A. Last one for B. But system will receive only this one. But it doesn't work. This problem comes. That's what this one must be last. Suppose if you write like this, integer A, comma, integer 3 dots B, valid. First one received by A, remaining all received by B. Like that. Okay. And one more thing, float 3 dots, also not valid. Must be last. It is last. It is one more is there. Only that rule only. See, again same error. Must be last. So Varrock's parameter must be last environment. 2 also you cannot write. Must be last means 1 only can write last. One more if you write also error. So write that point. Note. Varrock's parameter must be last parameter. Varrock's parameter must be last parameter in a method. Varrock's parameter must be last parameter in a method. Or so if you write examples, void display integer A, integer B, invalid. Void display integer A, integer B, valid. Void display integer 3 dot A, float B, invalid. Void display integer 3 dots A, float 3 dots B, also invalid. These are some examples. Is it over? Invalid, valid, invalid, valid. Year I given first. Year last I given valid. Year first I given. Even different type also not valid. 2 also not valid. Is it completed? So Varrock's completed. Static imports already completed. No? You can avoid class name with static members. This is not completed. This is not completed. This is we'll see tomorrow. This is also we'll see tomorrow. This is also we'll see tomorrow. Remaining already. This is also we'll see tomorrow. After that, Java 8. For tomorrow class, you prepare and come anonymous class. Anonymous class compulsory required. Otherwise, again, I have to teach. Okay, prepare and come. We'll see continuation tomorrow.